To make it easier to see how the different parts of this program work, this is a quick walkthrough of the code for the second part of the Snake tutorial video, so that you'll be able to get a close-up look at the code. And if you're typing in the code from the PDF, you can check with this video to see what each part of the program is doing. And we'll go top to bottom here, and I'll also do a quick step through just to describe what each part does. So from the top, this is importing the turtle library so that we can use turtles. Then we get into a section where in this program we are defining a bunch of functions. All these def statements are defining functions that this program will use. And so I'm going to go through those function definitions. First, we have a function that we created to draw the borders around our game area with turtle commands. Then we have a set of functions that respond to the user input. When the user clicks a key, the program has to call one of these functions to set the behavior that the sprite or the turtle is going to engage in during that time in the program. In other words, if the user hits the key that indicates that they're going left, in our program that is the A key, but you can't see that here. So if it's time for the sprite to start going left, then go left is called, and it sets the behavior to left so that as the game loop repeats, it's going to keep going left. So that's why it stores this the state of the behavior, because once it gets into the going left behavior, it stays in the going left behavior until that changes. So that's what each of these do. Each of these calls set the current behavior. So if those previous functions set the behavior, these functions actually make the behaviors happen. These are the functions that are called during the game loop over and over again that create small actions that, when done over and over again, create behaviors. For example, this is a tiny step right, and if you keep calling this function, the sprite will move to the right, and it will keep moving to the right. The same thing with step up, step down, and step left. This section of the program is the functions that create the sprite behaviors. The next part after the behaviors is a function that checks whether the sprite hits the wall. And this is a special function because it returns a value. These other ones previously didn't return values. A function that returns a value can not only do something, but then it can send information back to the part of the program that called this function. Just a quick dive into how a function works. Functions always look the same. They have the word def at the beginning, then a space, then the name of the function, and then an open and close parentheses, and then sometimes you're sending information into the function, not in any of these functions this time, but the parameters would go into the parentheses. I'm not going to talk about that in detail right now. And then the first line of the function is the function definition or the function header. That line ends with a colon. And then every line after that in a function is going to be indented 2 spaces. So that's how we know these lines are part of the function. You can actually have an additional space here and it would still be part of the function. What happens is Python knows that the function ends once code is no longer indented after it. So this is all part of the function because it's indented immediately after the function header. And these are all turtle commands, and you can look up the turtle commands in Python on the internet and you'll see what these different commands do. So we also have a print command that prints to the console. That's debug output so that we can see in the console that we got to a certain part of the program and check to make sure it's doing the thing that we expected it to do. Okay, so in the collision with wall function, it also has if statements and some turtle calls. So let's take a quick closer look at what it's doing there. It's creating a variable called collided, and that variable is going to start out with the value of false. Collided is a Boolean variable. We know that because Boolean variables can have two values, either true or false. This one's starting out false. Now it's the collision with wall function is using if statements to try to determine if collided should be set to true. If any of these checks turns out to be true, then it's going to say that we collided with one of the walls. So looking closely at one of these checks, it's checking if the x coordinate of the turtle, in other words, where the turtle is in the horizontal direction, if that's greater than or equal to 200, then that means we're at a wall. So collided is true. So the same thing for negative 200. If we're less than or equal to that, we've collided with the left-hand wall. This is the right-hand wall, the left-hand wall. The y-coordinate is greater than or equal to 200 means that we've collided with the top wall, and y-coordinate less than or equal to negative 200 means we've collided with the bottom wall. So if any of those are true, or I should say, if any of these checks come up true in these if statements, then it sets the value of collided to true, and then that value of collided is sent back to whatever part of the program called this function. So it's going to get a false if we didn't end up colliding with the walls, but it will get a true if we did collide with the walls. All right, now we get to the main part of our program where we see the order that the functions are called. We can also see when the functions are called. So the first thing that we do is we get a reference to the screen. I talked about that in part 1. And we set the background color of the screen area. I also talked about that in part 1. Then we call draw borders, which we saw earlier. If you double click in Replit on the name of a function, it will highlight the function. So when I scroll up, you can see that this is the draw borders. So this is where it actually draws the borders. It calls the draw borders function. After that, we set up what we call key bindings. We tell the screen area, that's where the turtles are drawn. We tell that area to listen to keys, to the keyboard. So this is just a setup that we have to do in order to get it to listen to our keys. Once we tell it to listen, we start to tell it what to listen to. And the way we do that, I talked about this in part 1, but we use the onKey function of the screen. So we call the screen.onKey, and then we send onKey two things. The first thing is the name of a function in our program, and the second thing is the key that we are associating the function with. So in other words, in this case, we're saying there's a go up function that we want you to call whenever the W key is pressed. So this sets up that association so that anytime now while this program is running, if you hit a W, go up is going to get called. Okay. And what is go up? We already looked at that. Go up sets the state of the turtle's behavior. It sets the behavior to up. And that's going to be used in the game loop. All right, so once we've set these key bindings and we've associated those keys with different calls, now we're getting to the part of the program that has the game loop. So to set up the game loop, we set turtle.done to false. So we store the fact that we're not done until something in our program says that we're done. So we're setting done to false. We're not done. And then we're setting the default behavior of the turtle to write. In other words, it has to have a behavior to start out. That behavior is going to be moving to the right to start out. So now we have a game loop. I call this the game loop because this loop is going to continue for the entire time the game is running. And it's almost like the ticking of a clock. It will keep going until the program is done running. And every time through this loop, it will move a turtle along. It will allow a turtle to progress in its behavior. And we have 4 possible behaviors here. We have moving up, down, left, and right. If the behavior is up, we call step up. So we go 1 step in that behavior. The same thing for down, left, and right. And then once we've had a chance to progress the turtle's behaviors, whichever one of the behavior it's engaging in, then we do a check to see if it's collided with the wall. And if it has, we set done to true. So this loop will keep running until turtle.done is set to false. Because when turtle.done is false, then, until turtle.done is true. When turtle.done is true, then not turtle.done is false, and it won't go into this loop. The way while loops work is as long as the thing in the parentheses is true, you will enter this loop, and then it will go back up to the top and check again. And then if it's still true, it will enter the loop again. So what we need is something, if we need this whole thing to be true for it to continue, then turtle.done, when turtle.done is false, then the negation of that is true, not turtle.done. When not turtle.done is true, then this whole thing together is false, and then we don't re-enter the loop. So when does turtle.done become true? Well, when we've collided with the wall. And that's what this check is doing here. If we can tell that we've collided with the wall, then turtle.done is set to true. So once we are not in the game loop anymore, the final thing in the game is going to happen, and we print out a message, a failure message, game over, you hit the border, and then it just says done after that. So how is this program going to run? What is it going to look like? So after it does all this setup of these functions, it gets to the main part of the program, does a little bit more setup and some drawing, sets up the key bindings, and then for the most of the time this program is running, it's stuck in this loop. It just keeps going because turtle.done was set to false, so not turtle.done is true. So until that changes, it just keeps going. It checks the turtle's behavior, and depending on whatever behavior it is, it will advance the turtle along. And 2 things can stop this program. One is if you hit the, let me see this, in the key bindings, if you hit the X key, so done is called. So done, here's so done. So done sets turtle.done to true, and it prints out a test message. So what happened is turtle.done became true here. So that's one way the program can end, because when turtle.done is true, not turtle.done becomes false, and then we exit the while loop. The other way that the program can end is if we collide with the wall. If collision with wall is true, then it sets turtle.done to true. And so as soon as turtle.done isn't false anymore, this loop will not re-enter when it does its check, and it will just continue after the loop, and then it will be done. And that's an explanation of the different parts of this program. If you have any questions about any part of this program, please feel free to send me an email.